Welcome back. This is part 2 of the SVG series, how to get an SVG file into Blender and turn it into a 3D shape with geometry nodes. That's what we did in part 1. In this part 2, we're going to look at how to expand on this and how to emboss or engrave this 3D logo that we now have into another mesh. Let's jump into Blender, and this is where we left off in part 1. And actually, I forgot to do one little cleanup thing while creating this 3D mesh, because we created this path at 3D and we were extruding this, and then we added the original geometry back at the back side of the logo, and then we joined them. And then we merged by distance. However, the normals of the back are still pointing upwards, so they're pointing inside. If you have a watertight mesh shape in Blender, the normals are supposed to point outside, to the outside of the mesh. So we can actually visualize this using the face orientation. So the faces of the mesh, when they are blue, the normal is pointing outside. So the blue is the outside of the face. However, when it's red, it means it's the inside face. So this is it kind of looks cool, but it means the mesh is not very clean, and the normals of these red faces are flipped. And it doesn't matter if we turn this into triangles or n-gons. It's simply the fact that we took our original filled up curve, which looks like this. I'm using a viewer node, and I'm only applying this to this shape right now. So let's focus on that. This shape, it's pointing upwards, and so the other side is the back side of the shape. And we just used that to join it with whatever we got from here, which is this shape. So here you can see the outside is nice and blue, and then the inside is red. But then we just join it with this, which is the original, and that's what we get here. So the way to fix this is using a node called flip faces, I believe. Yes. And we can just simply add that to the original, and that flips this part. So then we get this. So now the inside is pointing up. And when we join it like this, we get a proper mesh that's watertight, or actually here it's not watertight yet, but when we merge by distance, we get a watertight mesh that has proper normals. So doing that will fix all the other shapes as well, because they all use the same nodes called path to 3D. And this little sequence of nodes is actually a very common thing that would be nice to have in a group. So I have this mesh here, and I'm pretty much solidifying this mesh. So we kind of want to make a solidify node group. So we take some kind of mesh, and the output is another mesh. So it's these 4 nodes that we want to group. So you select them and then hit Control G to group this into a node group. And the input is a mesh, which makes sense. The output is also a mesh. So let's go hit N to go into the group properties. And we can rename this by double clicking it to mesh, to just make it clear that we get a mesh out of this. And then we can expose some settings to the outside by dragging them into the group input. So what would be nice to have? Maybe the offset scale, which is set to 0.1. Maybe we set it to 1 by default and then drag it in. Now we have this offset scale here, and when we click that, we can see all kinds of stuff. The subtype is a distance. If you set this to distance, then this becomes then Blender knows this is a distance, and you can enter the value in meters or centimeters or anything like that. So that kind of that's useful. And then I would like to set the minimum to 0, so you can't set negative values here, and that's cool. Maybe another one we want to expose is the merge distance. So let's expose that. It's called distance. To make it a little bit more clear, let's call it merge distance. And something I also like to do to just reduce the amount of long node connections like this is to just duplicate the group input and connect it like this. Then we just if you name your inputs well, then it's still clear what it is, and it just cleans up the graph a little bit. And you can hide this by hitting Control H. That will hide any unused inputs and outputs. So we can also do it here. I don't want to do it there, but I just want to do it to the group inputs, because we don't use the mesh and the offset scale. So we just Control hide this, and we just have the merge distance here, which goes into the merge distance. So that makes a lot of sense. And now we have a nice group. All that's left is to give it a name. So let's call it solidify mesh. And now we have a nice solidify mesh. It's a bit large, so let's set it back. The offset is set to 1 meter now. Let's set it back to 0.1. And now we're back to the original. We can turn off our face orientation, and we're back to what we had. Yeah, to make this a little bit more easy to manage, I want to just join all of these curves into one object. So let's do that. We can, well, I can do it here. I just increase this view a little bit. And I also want to make the kind of center the logo a little bit, because now we're like, it's centered. The lower left corner is kind of in the center, but we can take this object and use the Y center really nicely, because it's kind of symmetrical in the Y direction. So I can go to Object, Set Origin to Geometry, and that moves it there. And then I will also select these two objects, and then go to Object and Join. So now these are all joined into the same object, all these curves. And obviously they get the same material, because we set the material to our object in the part 1. And for now, I just want to remove the material and just not be distracted with that. So let's just remove that, and we have the blank clay material from Blender. And now we can reset the location of this object with Alt G. Yeah. And then I want to also center it in the X direction a little bit more. And I just eyeball this. Something like this looks fine. And then we can go back to Object, Set Origin to 3D Cursor, because my 3D cursor is exactly at the origin. So now we have a nice centered shape. And the location is set to 0, rotation set to 0, and scale to 1. So that's good. And now we just have a single object that we can deal with. And we still have our geometry nodes path to 3D. And we can set the offset like this. So now I want to start embossing this onto another object, or engraving it into another object. So first we will need another object. So I'm going to move this out of the way. Let's move it into the Z direction 2 meters up, like that. I'm just going to add a simple cube, and let's scale it into the X direction 4 times and in the Y direction 2 times. So we have like a little cube, and it's kind of boring to just, we could already go ahead and place this kind of like this, and then use a Boolean modifier, and then we're done. Either to extrude it and emboss it, or engrave it. But I want to do some more interesting stuff with geometry nodes. So what I want to do is, I want to completely transform and displace this cube and make it very random, and then try to still see if we can emboss or engrave the logo in a good way. So let's try that. So I'm going to reset this back to like 2 in the Z direction, and I'm going to take this cube and I'm going to add some modifiers to it. I could do it with geometry nodes, but that's not really the point of this tutorial. So I'm just going to start with remeshing this to add some more resolution to work with. And as you can see, the remesh has some distorted rectangles here. I want them to be square. So the reason for this is that we have a non-uniform scale applied to this object, which you can see here. We have 4, 2, 1. So I just want to apply this scale with Control A. And now we have nice squares. So that's cool. I want to change this to smooth. And This is actually fine. I want to add some more. I like the smoothness of this because we're going to displace this, and then it's just nice to have some smooth shape. So the next one I want to add is subdivision surface, and maybe set this to a higher value like 3, and turn off optimal display so we know what we are dealing with. And this is a nice amount of resolution. And then we can go ahead and displace this. So let's use a displace modifier, and we're gonna add a texture. Currently we don't have any texture, so let's add a new one. And I call this, I wanna do 2 displace modifier. One large noise. And I call this, let's call this large displace. And we can go, we created this texture, which we can change if we click here or just hop over to the texture tab. And currently the type is image or movie. We want to change this to clouds, which is just kind of smooth noise. Blend original is fine, soft is fine. I want to change this to color. So we have RGB, which we can turn into XYZ. And I want to increase the scale a lot because this is supposed to be the large noise. And we can set the size bigger than 2 by just typing it in. So let's try 4. And this is really large. I want to set the direction to RGB to XYZ because if you set it in the normal, the directions, it's kind of using the grayscale texture, and it's moving everything up and down into along the normals of the faces. But this is kind of an interesting effect, RGB to XYZ. I kind of prefer that one. And we can increase the strength a little bit. Yeah. Okay, so this is some large scale noise, and then we add some detail by just duplicating this. I don't want to spend too much time on this, but maybe the small noise. Okay, now we have something interesting to work with. Let's see if we can take this object and emboss or engrave our SVG logo onto it. And I want to do this in geometry nodes, but I want to apply the geometry nodes to this object itself, because that makes the most sense to me. We are modifying this object by cutting text or embossing text onto it. So let's minimize this one, and we add a last modifier, which is going to be geometry nodes. And what I want to choose is the path to 3D to get something to start with. But this doesn't make any sense because we're starting with a mesh, and this is supposed to be a path. So that doesn't make any sense, but these nodes are useful to have a starting point. And I just want to copy this and rename it to Engrave path. Something like that. So we want to take a path object, which we want to choose over here, and we want to engrave it into our main geometry. So the way to do that is take an object, and I'm going to make this a little bit bigger. We're going to take an object info node, and we're going to expose the object to the outside, to the group input, and that makes it available over here. And I'm going to rename that to our path object so that it's clear that it's supposed to be a path. And our path object is going to be our icon. And let's rename that to Blender Grid logo. And we don't really need this collection anymore, so I'm just going to delete that. We don't really need this collection. I'm just going to keep it simple. So we have our cube, which is kind of looking like a potato right now, but that's what it started with. We can still hop into edit mode, and it's kind of a cube. So that's that. And then we have our logo. And that's what I want to choose over here, like that. And now we get some geometry. So instead of applying this sequence of nodes to the mesh, I want to apply it to our path object. And that kind of does something like this. I'm not entirely sure what is going on. Let's see. Oh, okay. Yeah. So we're applying this to the object, but first, when we look at this object, it has this geometry nodes applied. So I want to just save this for later use and make sure it doesn't get deleted because we're not using it, so I want to protect it. And then just remove this whole thing. And now we can see our cube became our 3D logo, because that's all we're outputting right now. If we want to see, I can kind of duplicate this, and if we want to see the original, we just plug it in like that. Okay, so the first thing I want to do is kind of take this and project it down onto this geometry. And there is a really nice node for that in geometry nodes called ray cast. So let's get that. Ray cast. And it has a lot of inputs and outputs. What we want is a target geometry, which is going to be this mesh. And then we can hit rays from our logo shape onto it in the default is the negative Z direction, which is what we want in this case. And then we can get the hit positions. So let's try that. So we want to take the target geometry, which is our original mesh, this one. And then we want to set the position. Let's remove this solidify mesh for now. And let's look at, this is our logo. Actually, let's remove that one as well. So we just have this logo. And as you can see, the position is reset. The way to fix that, it depends on what you want. But in this case, I want to have my object relative. So now it's exactly on top of our original logo. And when we move this around, rotate it, whatever, scale it, it kind of moves along, which is useful as a way to control where our logo is going to be placed. So I want to set it to relative. And now I want to just try this raycast node by using a set position node on this geometry. So by default, it's using the original positions, but instead of the original positions, we can use the hit positions. And if we do that, you can see it works because we get a ray which has a direction in the negative Z direction. So that's straight down. And whenever it hits our target geometry, we get a hit position, and then we set the position of our original curves to that hit position. And then you get something like this. And you can move this around. That's a nice way to control this. And it follows along. You can rotate it, and it just follows the shape of our original mesh, which is looking like this. And you can view both by joining them. So let's join geometry, and we can join this geometry with our curve. And now you can kind of see it's kind of laying on top, but sometimes it's slightly below and sometimes it's slightly on top. So it kind of looks a little bit crappy, but we can offset this a little bit in the positive Z direction, maybe 0.01. And now we can see the curves laying on top of our mesh, which is pretty cool. And currently it's still curves. So let's try to take this and then fill the curve. Let's see what happens when we try that. I can just remove this with Alt and place it here. Let's see what happens. And suddenly it disappears. Let's see what we get when we just use this. And as you can see, we kind of lose all that nice displacement by using the fill curve. And it doesn't matter if you set it to triangles or n-gons, but if you mute this node, we're back. But filling the curve does something to the positions. And what it basically does is it turns the curves into 2D first, and then it's able to fill them. And that's kind of a similar thing we saw in setting this to 2D versus 3D. When we want to fill the shape, we have to set it to 2D, and that is also what the fill curve in geometry nodes is doing. It kind of removes all the Z coordinates and just turns the Z into 0, and it only keeps the X and Y. And if you look straight from the top, we can see that. So if I hide my original logo, we just get this. And now turning this on and off doesn't do anything to the shape when you look at it from the top. When you look at it from the front, you can see we first have this, and then when we use the fill curve node, it just flattens it. that doesn't really work. So instead of setting the position on the spline, on the curve, we have to first fill the curve and then set the position. So let's remove this and apply it later. So first we want to fill the curve, then we want to set the position to the hit positions. And that kind of works, but it doesn't really work because we want to set that to the top. So let's remove this and let's view both. So that kind of applies it to the bottom of the mesh instead of the top. And the reason for that is that the ray direction is down. So we could change this to a positive Z direction, and that kind of works. But instead, I want to make it work in a different way. I want to kind of recover the original position of our original curve, because that gives us a lot of control. So the reason we lose this is that we use this fill curve node, which resets the Z location. So I want to recover the Z position. So after this fill curve, when we look at this, we are back at Z 0. So the way to fix that is to translate this back into position. The rest is still intact. So if let's look at this and let's remove this. So after the fill curve, when we look at the group output, we can still rotate, we can still scale, we can still move in the X or in the Y direction. Only the Z direction movement is kind of lost. And I want to just recover that to have better control over where we place our logo. So the way to do that is either we can set this back to original and then we use a transform geometry. So after the fill curve, we transform the geometry back to our original location, original rotation, and our scale. And that kind of moves it back. And when we now change, when we rotate, it rotates with. When we rotate our logo, it follows. When we rotate, when we scale it, it follows, and moving it in the Z direction, it follows. Okay. Let's undo all of that. Okay, so that works. However, if we move the cube, it stops working. So I want to set this back to relative, but that breaks it as well, because now if we rotate the logo on the cube kind of rotates double. And when we move it, it moves double the amount. So that also doesn't work. So we have to do some kind of hybrid way. So I don't want to use the rotation. I don't want to use the scale because those are still preserved. And in the translation, I only want to use the Z direction. So the way to do that, you could split this, you could separate the X, Y, and Z values and just reset, only use the Z direction. But what you can also do, which is easier because it's just a single node, is using a vector mat node and set this to multiply. And then you multiply it with 0, 0, 1. So that kind of removes the X and Y, and it only uses the Z component of this vector. And now setting this to relative, which kind of takes our rotation scale, X and Y, and then taking the Z location and adding it back after we fill the curve kind of fixes our problem. So now we can go back to the logo. We can do anything we want with it. We can rotate it, we can move it in the X direction, we can move it in the Y direction, and we're back at our Z. So if we hide this one, we're back at our original position, and that just gives us a little bit more control. And when we move the cube, our object stays where the original logo is sitting. So that's very useful. All right, so now we have a way to get our filled curve back to the original position just for control. And now we can set the position using this ray cast. So we take the hit positions and we use that for the set position node. So now we go back and we now have a mesh that's filled in, that's laying on top of our original cube our deformed cube. So now we can take this and we can join it. So let's remove this and we can join this with our mesh and we can move this into the output. And we can get rid of the viewer. And now we can see we have our mesh on top of our cube, and the offset is a little bit large right now. So let's reset this offset to 0.01 or something like that. That looks pretty good. A way to view this a little bit better is to change the material of our logo. So we can do that over here with a set material node. And we can set it to a different color like black. And now you can see this a little bit better. And the inside of the letters are not always above the mesh. A way to add a little bit more resolution to the inside of the letters is, well, first of all, we can instead of n-gons, we use triangles. So that gives us a lot more to work with. So that already fixes a lot of that. But then when you look at these lines, these edges are pretty long and they're completely straight, even though the surface below that might be curved. This can only be a straight edge because it's a single segment. So we can add some more in the middle of that after our fill curve by adding a subdivide node in there. Subdivide mesh, that's like a simple subdivide and that's all we need. So let's add that here, and that, as you can see, adds like midpoints in there, and it allows us to curve the letters a little bit more, and you can add as many levels as you want. But I think one level is already giving us enough. And now we have a flat logo sitting on top of our random surface, and we can move this around and it just follows. We can rotate it, we can scale it, and we have all the control we need. All right, that's most of the way there. The only thing left is to extrude this again, and we still have our solidify mesh. So we solidify this surface and then we cut it out of the shape with a Boolean node. So let's do that. So let's take our set position, well, whatever we got there, and we solidify our mesh, and let's see what we get. Now we have a solid version of our logo. But if you might see this better if we increase the offset. If you increase this offset too much, you can see the shape kind of gets messed up. And the reason for that is that we move this offset in the normal direction, and the normals are kind of random right now because of this random noise on this surface. And that might be what you want, but maybe we just want to move them straight in the Z direction. And the way to do that is to slightly modify this solidify mesh group by exposing the offset vector that we have here. So let's take this group input, and there's no way to add another group input right now. So let's hit Control H again to unhide the unused group inputs. And now we can take the offset and move it and expose it to the outside. And this also resets it, because if you don't connect anything to the offset, it will be set to the normals, I believe. If you connect it, it will be set to a 0 vector. So that's why this changed. But that's okay. We can fix that outside of the node group. So let's take this, and the only thing I want to do is move this up because it's kind of the most important one. So let's move this up over there, and offset is fine. And let's tap back out of this, and now we have an offset. So if we want to get back to the original, we have to take a normal node and connect it like this. That gets us back to where we started. But now we have a little bit more control over this input. So instead of the normal, we could simply get a vector, set it to 0, 0, 1 to point it straight up. And instead of the normal, we can connect that. And that gives us a very different result. And even though this surface here is curved, the logo points straight up, and that might be what you want, might also not be what you want, but at least we have a little bit more control now. And we can even blend between this. Instead of only straight up or only along the normal, we can use a mix vector node like this. And the default is just a 50-50 blend between the two. And we can start with fully in the normal direction, and then we can blend in to that. So now you have some control over how that works. And there's one other way to kind of clean this up, and that's by blurring the normal. Because right now, every single point has its own normal direction, and that makes it kind of go all over the place. What I want to do is make the neighboring points kind of point in the same direction. And this mix node is kind of doing that by just pulling it all back to a 0, 0, 1 vector. But what we can also do is using a smooth node. So let's try that. So smooth, you might think of a smooth node by, a blur node. Yeah, a blur attribute node. That's the one I was looking for. So blurring, or this is kind of like it. Blurring is mostly used for images, but you can also blur other attributes. So in this case, we want to blur the normal, and that is a vector. So we will have to set this to vector and then plug it in between here. And this really doesn't do anything because the factor is set to 1. So let's look at the normal. And turning this off and on kind of already fixes a little bit, but we can increase this by turning up the iterations to something like 8, and that really fixes a lot of these letters. And it's still way too far extruded, so that's just to see more of the details here. Like this E here is still pretty messed up. So maybe we have to increase this to like something like 32. And turning this off is this, and then turning it on looks like this. So that kind of smooths out this noise, but it still points in the normal direction of this surface. So that's kind of nice. And then we can still mix it in with the straight solution, like this. So maybe just use 50-50 in combination with a blurred normal, and that gives us a really nice way to control how this text is extruded instead of simply extruding it in one direction. Okay, and now I can set it back to something like 0.1, which is what we started with. And now this looks pretty clean. All right, so now we have a mesh. Let's check the face orientation, and that looks good because our solidify mesh takes care of that. So now we have a watertight mesh that is following the random surface of our object. And we can view both by joining this geometry. So maybe I want to just solidify the mesh that has this material applied. Then it's black. And then I can join, instead of this flat mesh, which looks like this, instead of that, I want to join the, let's remove this, and join the solid mesh. And that looks like this. And you could already render this, and this is an embossed version of the logo onto the object. And you could render this, and that's fine. But if you want to turn this into a solid single object that is watertight, you have to use a Boolean modifier, and or a Boolean node. You can either use a Boolean modifier if you turn this into a separate object, but there's also a Boolean node in geometry nodes. So let's do that now. And first, this text is kind of hovering slightly above the surface. If we want to apply a Boolean to this, we kind of want to do the opposite. We want to move it down slightly into the shape. And both for embossing and for engraving, this is useful. So let's try that. So first, let's reset this offset to 0. this was our set position node, and this is what we used to move the text up. But let's reset that to 0. Now it's laying exactly on top of the surface, but sometimes it's slightly below and sometimes it's slightly above. So we kind of want to move a little bit further down in order to make the Boolean operation work well. So what we need to do is we could either keep it very simple and move this down by minus 0.01 or something. That does the trick, but we can make it a little bit cleaner by using our blurred normal that we calculated here with these 3 or 4 nodes actually. And we can take this and let's reorganize it slightly. And we could take this direction that we calculated here and then scale it. So let's take a vector math node and set it to scale. And that's 1 by default, which doesn't do anything. But if we do that, we move it up by 1. And that looks like this. But instead of 1, we can set it to minus 0.01. And instead of straight down, we just go down into the surface a little bit more. So on this side of the surface, we move, instead of straight down, we move a little bit more into the surface like that, because we calculated this direction over here with this blur and our mix. So let's look at this from the inside to see if this looks good. And I think it does. We can always increase it to 0.02 if we think we need more. But I think this works well now. And these 2 shapes, this original mesh of the cube and the solidified logo, are nicely intersecting each other now. So now we can take them and do a Boolean operation on them. And there's a node for that called Boolean mesh Boolean. And let's start with taking a union, which is kind of embossing the logo on top of the mesh. And I don't know if I want to apply this material. So maybe instead of adding it here, I want to remove it and add it over here, because it's kind of nice to see a different material for the logo. But for the Boolean, I don't need that because it becomes one shape. So then we can use the set material only when we look at it from the join geometry. And when we do the Boolean, I want to use my original geometry, which is this, and plug that into the mesh Boolean. And then take our solidified logo over here. And this is a pretty slow node. So currently things are pretty responsive, but once we connect this to the output, things become a little bit slower. So let's try that. And you can already see we have to wait a few seconds, and now we have our embossed logo. And as you can see, it's not completely working. The E over here doesn't work. And that is probably because the way that some of the vertices of this mesh are too close to the vertices of our logo. To clean that up, what I usually do is play with these settings, and these make it even slower. So usually self-intersection, turning that on, it makes the Boolean operation a lot slower, but it usually also makes it more accurate. So let's try that. And that takes a while, but there we go. Now the logo looks good and it's properly embossed. And if we check the face orientation to see if there's anything weird going on, we can look at this from the inside and it's all looking good. And from the outside as well. All right, cool. And now, if you now take your logo object and you just want to move it around, it's very slow because this takes a couple of seconds to calculate. So what I want to do is I want to add a switch, because that just makes it easier to work with and makes it more responsive by being able to switch this on and off. So when we turn this on, I want to see the Boolean. When we turn it off, I want to see the join geometry with the different material. And connecting this for whatever reason also refreshes everything. So I'm just gonna, to keep things fast, I'm just gonna temporarily disable this node. And there we go. And now I want to set the join geometry output to false. Then this output goes to the final group output. And then I want to expose this switch to the modifier by dragging it in like this. And then I want to rename it to something like use Boolean or something that makes it clear what this does. So now when we look at the modifier, we have a use Boolean switch. And when we turn this back on, everything should still be fast because it's not being used. And now you can, let's turn off the face orientation. Now you can take your logo, move it around, and it's very responsive, and you can just place it wherever you want. And then you can take, once you have it placed, you can use the slow Boolean operation, which just takes a few seconds to calculate. And if all goes well, we should see the same shape, but now it's a single mesh and it's all watertight. So this could be useful for 3D printing or something if you want to, if you really have to make this a solid mesh, or if you use a different kind of material like a glass material, where it's important that the inside is properly managed. So that's embossing. Now we can look at engraving, which is very similar. It's just a different kind of Boolean operation, and we have to move the mesh a little bit further down. So let's turn this back off. And instead of a union, we have to use a difference. And instead of plugging them both into the mesh 2, we have to plug the original into mesh 1, the original cube mesh, which is the group input geometry. And then we cut out the solidify mesh or any other mesh. You can cut out multiple meshes. And I'm gonna keep self-intersection turned on, or actually let's just see what happens when we turn it off. And that's good. And now I wanna move this a little bit down. So we can add some nodes to make the control of this placement a little bit nicer, but I don't wanna make this tutorial too long. And that's pretty basic stuff. So let's just do it quickly without exposing the settings. So instead of the scale to 0.02, I want to set it to minus 0.1. So that moves it down a lot. And then I want to, let's see, offset this to 0.12 maybe. Yeah, that moves it out a little bit further. And when we look from the inside, we're down a little bit deeper. And I think we're ready to turn on the Boolean. So now we can do anything with this logo. We can also move the original cube object, or even jump into edit mode, move the vertices around, anything we want. We can even change the noise settings, and it all responds, and it's all, yeah, very, very nice. So now we can turn on Boolean and see if that works. If it doesn't work properly, we might have to improve the Boolean accuracy by turning on self-intersection. So let's take a look. Yeah, it doesn't work for every shape. So let's turn on self-intersection again, and it will take a little bit longer, but that should fix everything. And there we go. And now we have an engraved version of the logo, and we can check the faces again. It's always good to do from the inside. It should all be red. And that looks good. Cool. So this is how you kind of engrave the logo or emboss it onto a random surface. Another use case would be to engrave this onto a curved surface, like a cylinder shape, maybe a bottle, and then also maybe a spherical object. And that's something I want to cover in part 3. So stay tuned for that. Hope you enjoyed this. If you have any questions, you can leave them below. And yeah, I'll see you in part 3.